Good morning, everybody. I wanted to let you know how very proud of you I am for doing such a great job of going on, watching the videos, giving the feedback. This is just going to make it really good for you, and it's also encouraging to me. I miss you all, and I hope that you're able to really understand everything. Keep the questions coming, and I'm going to do my very best to keep up. And hopefully we'll get to see each other pretty soon here. Anyway, today our lesson is on binomial radical expressions. Remember, radical is when you've got this root sign involved. It works very much the same as when you just have a normal a normal variable and you're trying to put like terms together. So for example, if I have 1 square root of 2 and we have a 5 more square roots of 2, altogether that will make 6 square roots of 2. And if I have 2 cube roots of 5 and I'm taking away 7 cube roots of 5, that's going to just give you -5 cube roots of 5. And here, once again, because we have like terms, you can just put them together and get your -1 or just negative fifth root of x squared y. So once again, just putting like terms together, like terms isn't exactly the right word, but I think that it expresses exactly what you're doing very, very, very well. You can only put them together if they have the same index and the same things underneath the radical. So you've got to watch out for that. So just take a second here. You might want to pause it to make sure that you can actually do this before I jump right into the explanation. This first one here, well, that one they can't combine because it might be a root of 5, but this is a cube root, this is a square root. They're not the same. They're asking for a whole different number. So these things can't go together. These, though, can go together and give you 11x square root of xy. And then these two can go together and give you -7 times the 7th root of x squared y. Because you're putting the numbers together that go together. This whole thing, even this x, is part of what's alike in these. So you're really kind of undistributing the 8 and the 3 and getting you the 11 there. All right, so you're looking for like terms just like you do with every other normal everyday variable. So hopefully that part's pretty nice and simple. Sometimes when you have something like this, it looks as if there are no things that are alike to be able to share, but what you really need to do in that case is you really need to simplify before you add or subtract. So if we're going to simplify this before we add or subtract, what we need to do is we need to take each one of these and break it down into its simplest terms. So I'm going to take my 12 and I'm going to prime factor it like we're used to. 3 and 4, 2 and 2. So when you simplify this out, we have a pair of 2's and a 3. Some of this you're hopefully able to do mentally by now. So we end up with 2 times the square root of 3. 75 breaks down into 3 times 25. Think money. That sometimes helps out. And 5 and 5. So once again here we have 2 5's and a leftover 3. So that would give you 5 times the square root of 3 minus 1 times the square root of 3. So with that we have 2 plus 5 gives you 7 minus 1 gives you 6 times the square root of 3. So you can go ahead and write that down, and your answer then looks like this for that problem. 6 times the square root of 3. So simplify first, and after you've simplified, you check to see what have the same radical and the same number so that you can see what can get put together. Take a minute here. You might want to pause this and then try to do this on your own and see if you've got the right answer, and then fast forward me. Here we have the 250. So we have to break down our 250. I'm seeing 25 and 10, but you can break this down in whatever way that you want. And then I'm seeing 2, and I'm seeing 5, and I'm seeing 5 and 5. Once again, for our roots, and somebody had asked a question also that they weren't clear on simplifying the roots. So this actually kills two birds with one stone, because I'm getting to re-explain this. You prime factor, and you're looking for the groups of 3 here because our index is 3. So we have the cube root. So 5 times 5 times 5, you have 1 5 that came out, and a cube root of 2 that's left in. And then we're going to simplify 54. Okay, 54 is 9 times 6. And we have a 2, and we have a 3, and we have a 3, and a 3. Okay, some of you without even trying are starting to do these mentally, because I'm looking for a cube root, and I've got 3 3s and a 2. So the answer here is the 3 comes out, and I've got a cube root of 2 left over. And 16 breaks down into 4 and 4. Each one of those breaks down into 2's. So once you've got that, and you've got 4 2's, you have 3 that would give you the cube root of 8, which gives you 2, and 1 leftover lonely 2 inside. And now you've got the terms that are like 5 plus 3 is 8 minus 2 is 6. And that would be how you would simplify and solve that one. For those that like colors, there's the color-coded version of it. That's also in the notes section, where you can just look at the notes without the verbal explanation of that. Multiplying binomials. This is an interesting thing. This is where we go back to multiplying and distributing and simplifying. So you know how to do the basic thing. All this, you know how to do the basic thing. It's just a matter of putting it all together in a new way. So we're going to take a look at this. And when you do this, we multiply this one times this one, the 3 times the 2. Make this a little bigger to see. And we get 6. 3 times 4 square rooted. Now this one's interesting because this is 5 times 4, which gives you 20, times the square root of 4. Square root of 4 also. Here I have 20 times 2. 20 times 2, as you know, is 40. Line of 4. You end up with 46, leaving you with 46 plus 22 square roots of 2. Notice the thing that's different about these when you're multiplying binomials that include radicals is a lot of times I mean, it will break down so that your last radical actually disappears sometimes, especially if these things under the radical match, that's going to happen for you. So you've just got to be a little bit careful with that. We'll double check and make sure, yep, I got the same answer when I did it twice. That's good, means that I did it right both times. So again, you multiply, multiply, and then simplify. And that's really a lot of math is that you do steps one at a time. You never have to think about the whole problem all at once. Just what step do I do next? What step do I do next? One thing at a time. Kind of like how we're handling life right now. I'm trying to make myself do that. I don't have to figure out all of everything and get everything perfect right now off the bat with this whole distance learning thing. But I'm figuring it out and getting better and better at it and more efficient. And, the whole reaching out and being able to isolate physically, but not isolate emotionally or spiritually. We need to make sure that we stay in contact and we keep on doing what we need to do in all this, one step at a time, just like we do one step at a time in our problems. So here's another one step at a time. 4 times 7, 28. 4 times the square root of 5 plus 4 square root of 5. Minus 21 square root of 5. Minus 3 square root of 25. So I have 28. I have 17, minus 17 square root of 5. Minus 3 times 5, because square root of 25 is 5. So now I'm down to adding 28 minus 17 square root of 5 minus 15. So 28 minus 15 is 13, minus 17 square root of 5, and it's fully simplified, and here's your answer right here. Today, this whole lesson was relatively short, but I did have a couple of questions yesterday if I could clarify some things from before, so I'm just going to take another minute to clarify a couple of questions. Some of you were a little bit not quite shaky, not quite 100% on figuring out how to rationalize a denominator. So I want to go ahead and handle that with you. When you're rationalizing a denominator, you know how we were just back here in the other thing. Okay, when we were simplifying our radicals, you're looking for groups of however many, whatever index it is. If it's an index of 2, I'm looking for groups of 2. And if it's an index of 3, I'm looking for groups of 3 of whatever thing it is. When we deal with this, in order to make it so that everything comes out from under the radical, what we're looking for is to find groups of 3 things that are the same, so that when we square root it, our groups of 3 will all pop out. So when I look at this one, what I need to do is I need to figure out how to make groups of 2 here. I have 1, 2. I need another 2 to make a group of 2. So think about it where you're, like if you're playing a game and you're trying to gather up pairs of something. I have 3, I need another 3. I have x, I really need another x to make it a group of 2. But in order to keep it so that I haven't changed a value, whatever I multiply the denominator by, I also have to multiply the numerator by. So then therefore I'm just really only multiplying by a very, very strange looking 1. So when you do this, then you make one big fraction. So here I have 2 times the square root. I'm going to go ahead and simplify this to 6x. The denominator, though, I'm not simplifying because I want you to see what happens here. Here's a 2 and a 3 and an x and another 2 and another 3 and another x. And if you're looking for pairs, I have a pair of 2's, so the 2 can come out. The numerator still has 2 square root of 6x. I have a pair of 3's, so a 3 can come out. And I have a pair of x's, so an x can come out. So what we have here is I now have a situation where I have a 2 in the numerator and in the denominator, so I can cancel them out. As long as it's not under the radical. If the 2 was under the radical, you couldn't cancel it, but since they're both on the outside, we're dividing numerator and denominator by 2, and the final answer on this one will be 6x, square root of 6x over 3x. So once again, you're looking for what you can do to complete the groupings in the denominator. Your denominator is key here. Let's look at this one. This one, okay, try thinking ahead just a little bit. This one, we need to complete our groupings of 3. 12 breaks down into being 2 times 3. I have an x and I have a y squared. So in order to make 3 factors, I'm getting the 3 because the index is 3. Remember, I have to multiply numerator and denominator by the same exact thing. I have 2 2's here. I need one more 2 to give me 3 of them. I have 1 3, so I need 2 more 3's to give me 3 of them. I have an x. I need 2 more x's to give me 3 of them. And I have a y. I need 1 more y to give me 3 y's. Numerator and denominator match. So I can now simplify. I have 3x. I have the cube root of 6 times 3, 18. Pardon the blob there. X squared y. This is not going to simplify because we see there's no groups of 3 there. But the denominator, think ahead with me. I have 1, 2, 3 2's, a 2 pops out. I have 1, 2, 3 3's, a 3 pops out. I have 1, 2, 3 x's, and x pops out. And I have 1, 2, 3 y's, a y pops out. Then what you can do is you can cancel out the one that's in common. Here's an x that's in common. That can cancel out. So your final simplified answer here on this one would be the cube root of 18x squared y all over 2y. So you do just need to be careful and diligent. You're looking for groupings of 3, but then don't forget at the end to see if there's anything that can cancel. And be very careful not to cancel something that's already been brought out of the radical with something that's in the radical, because they have 2 different values. Okay? So I hope that clears that up for those of you that needed that to be explained again just one more time. Maybe I used slightly different words this time. Hopefully that came through clearly. Do keep asking your questions. I really do care about you and your questions. I care about your life and your families as well. And um, I'm still praying for somebody's dad in this class. Jesus, please touch him, Lord. And I pray that you would just bless everybody. Give everyone a great day today. In Jesus' name, amen.